Now we've come to question 7. Benzocaine can also be used to synthesize the dyestuff of S by the following route. Okay, so you have a benzocaine, and this is something that you don't know. This question, let's get enlarged. All right, this you don't know what box is this. Let's just look at the question. Suggest the reagent used in step 1. Now, I'm not very sure of this, but one thing you know that is related to dyestuff, so it has to bring you into the concept of the azo coupling process. Okay, so azo coupling process applied to phenylamine. Okay, phenylamine, whereby it will become the diazonium salt. Okay, so first step would definitely will be forming that triple bond NN plus. Okay, so the upper part you just maintain. Like this. And you have the N, okay, triple bond, yeah, triple bond plus. Okay, okay. You must put down the plus to show that the overall is positively charged. Okay, without the plus, it's wrong. And then after that, okay, this one form is called the diazonium salt, and it takes place for the next process, which is the azo coupling. Coupling means you can couple with this compound. So to answer this question, the reagent used for this step would be nitrous acid. Okay, or you can use the raw reagent, which is sodium nitrite, okay, plus HCl. Okay, or the mark scheme also accept directly nitrous acid. Okay, so they just need the reagent. If they need the condition, you have to mention the temperature as below 10 degrees Celsius. Now continue with the structure of S. Diazo coupling will bring you to substituting into carbon in position number 4 of the phenol. So you have the N triple bond. So this N will form double bond because it has to make another bond. You have to form the new bond with the 4th position of the phenol. Okay, it will be like this. All right. Okay, so 1 mark. Last one would be suggest how basicity of benzocaine would compare to that of ethylamine. Now look at the characteristic of benzocaine. All right, it has a benzene ring. All right, I think most of you have no problem mentioning that it is less basic than ethylamine. Okay, now it has to be coupled with the reason. The reason would be the lone pair on nitrogen is less available. Okay, so this one is the N effect. You can just add the N effect, less available to accept proton. So that leads it to be less basic, not release a proton. Yeah, if less available to lose a proton refer to the acidity. Okay, that one we use it for the comparison of carboxylic acid or phenol. So the reason for this one, you have two choices. Okay, either you talk about the characteristic of the benzene ring or the alkyl group. If you use benzene ring, then you should say since the lone pair on N is delocalized or overlap. Okay, delocalize over the ring. Okay, therefore making it less available. All right. Okay, you can also add that phenyl ring is an electron withdrawing group. Okay. All right. So 1 mark here and 1 mark here. If you choose to write for using a reverse argument, okay, then you should say ethyl amine is more basic because the lone pair in N is more available to accept proton. Okay, that's 1 mark. And keep dropping. Okay, this is due to the ethyl group being electron donating group, okay, or giving positive inductive effect. Okay, so there you go. See you, bye.